Hello everyone, welcome back to my YouTube channel. This is Sarita from Sri Venkateshwara College of Engineering, Megaluru. In this video, I am going to discuss about stacks in data structures and applications. The main contents are stack, the stack operations on push, pop, display, and the conditions on overflow and underflow. The stack implementation using an array, and the last is applications of stack. The stack. The stack is a linear data structure that follows a particular order in which the operations are performed. The order may be a LIFO condition or the FILO condition. The LIFO means the last in first out and the FILO means the first in last out. The LIFO implies that the element that is inserted last comes out first, and the FILO implies that the element that is inserted first comes out last. There are many real life examples of a stack. Consider an example of plates stacked over one another in the canteen. The plate which is at the top is the first one to be removed. That is, the plate which has been placed at the bottommost position remains in the stack for the longest period of time. So, it can be simply seen to follow LIFO or FILO order. There are two main operations in the stack, the push and the pop. The push means insert an element in the stack, and the pop means removes the most recently inserted element from the stack. Underflow happens when we try to pop an item from an empty stack. Overflow happens when we try to push more items on a stack than it can hold. The overflow and underflow conditions. The stack may have a limited space depending on the implementation. We must check the conditions to see if we are not adding or deleting elements more than it can maximum support. The underflow condition checks if there exists an item before popping from the stack, an empty one cannot be popped further. The overflow condition checks if the stack is full or more memory is available before pushing in any element. This prevents any error if more space cannot be allocated for the next time. So, here is a stack implementation using an array. We can see the program which is in C. We can see header files include stdio.h, the standard input and output functions, and the one more header file is include lib.h, the standard library function for memory allocations and other utilities. When it comes to constants, we define a maximum function which is as phi, defines a constant max with a value of phi representing the maximum number of elements the stack can be hold. When it comes to global variables, the int top equal to -1, which represents the top of the stack, initialize it to -1, and int stack of maximum has to store the stack elements, the function prototypes, the void push, void pop, and void display. These are the void functions prototypes. For void push, declaration of the push function, and the void pop is declaration of the pop function. Void display is declaration of the display function. When it comes to a main function, initiates an infinite loop, while one for a menu driven push, display a menu with many options to a push, pop, display, or exit, reads the user's choice the scanf, and uses a switch statement to call the corresponding function. After that, we use a push function, and this prompts the user to enter the element to push onto the stack. Check if the stack is full. If not full, increments stop and adds the element to the stack. When it comes to a pop function, checks if the stack is empty. If not empty, prints the deleted element and that decrements the top. At last, the display function checks if the stack is empty. If not empty, it prints the element of the stack from the top to bottom. So the program repeats the menu and operations until the user chooses to exit. This program provides a simple command line interface for managing the stack of integers. Users can push elements onto the stack, pop elements off the stack, display the current stack, or exit the program. Here we can see the output of that program which written in C. The stack menu, it displays stack menu, push, pop, display, exit. If we enter choice 1, it pushes the element. If enter a 2, it deletes the element or it pops the element from the stack. If we enter the 3, it displays the stack of elements, and if we enter a 4, it will exit from the program. So we can see here the output. Next, the applications of stack. Evaluation of expressions. The stack is used to evaluate prefix, postfix, and infix expressions. The other another application is expression conversion. An expression can be represented in prefix, postfix, or infix notations. The stack can be used to convert one form of expression to another. The syntax phrasing. Many compilers use a stack for phrasing the syntax of expressions, program blocks, etc. before translating into a low-level code. The next application is parenthesis checking. The stack is used to check the proper opening and closing of parentheses. And the next one is the string reversal. The stack is used to reverse a string. We push the characters of the string one by one into the stack and then pop the characters from the stack. The function call. The stack is used to keep information about the active functions or subroutines. Thank you. Please do like, share, and subscribe the channel.